Hello, I want to talk about SEH overflow. SEH is for exception handling, and how it's working, there is a chain of exceptions that when exception happen, it's gonna first go to check the first one. If it's not that, it's gonna go to the next one, and usually the last one is the general exceptions that is gonna be handled anyway with the last one. Similar to try and catch that we developer use for their coding. And what every item has is it has the handler, which is a pointer to a piece of code that handling that exception and saying what to do when this exception happen, and the next SEH record pointing to the next exception. Now how we can overflow that is that let me go to this PowerPoint slide. It happened like this. In the stack, when the exception happen, what we have on the stack is that we have the arguments, we have the SEH pointer, and the next SEH pointer, and then we have a SEH handler, which is the pointer to the exception code, and then local variables. When there is a buffer which get the input from the users, it's gonna be on top of the stack that we have it. This buffer gonna be passed as the input for exception handling. So what we're gonna have in the stack is gonna be, after overflow, we're gonna have, it's gonna go to check the SEH handler and continue running from there. To overflow that, we're gonna pass input to the that is in the as a local variable, as an argument is in the stack, and this argument gonna be overflow the SEH pointer and SEH handler. To have a successful execution of a shellcode, what we can do, we can put a SEH handler to point to somewhere in the memory that has the code pop pop return. And why we have this, it pop pop will gonna do the popping the argument, and when it's returned, it's gonna return to where the top of the stack showing, and the code gonna pointed to SEH, next SEH. There we can rewrite it with EB06. It means that jump 6 byte, and since every item that we have in the stack is 4 byte, so we can continue adding it to 9090, which gonna be the null instruction for null, and then or no operation, and then it's gonna jump over SEH header, that is the address to the code, the exception code, which is 4 byte. After that gonna be here, which gonna be, we can fill it with the shell code, and obviously with some no operation and shell code in case there is some other stuff in the stack. So if we're gonna be able to find where SEH pointer is, next SEH pointer is with this location, we can fill it with EB069090, and then the other one with the address to pop pop return and the shell code. So let me show you how we can, I have it here. Let me go to the samples that I have here in my VM. Oops. Here in my VM is a Windows 10. There I can use Python to create a character. Here I write 700 A character. I'm gonna copy it. That's what I need for my overflow. Oh, sorry. Okay. And then let's go to open. I'm gonna open one again here. What I did in immunity debugger, I'm gonna do that, but before that let me show you in what you need to do for the configuration is go to system system security, I think systems system configuration to make sure. Let me bring it from my PowerPoint. What we need to do for make this happen, I need to disable all the protections against overflow, and you need to go to Windows Security. There in app and browser control, go to system setting. There you have to make them off, including exception chain. You have to make it be sure it's off, otherwise you won't be able to do SEH. That's what we have it. I already did it in my Windows, so I'm gonna leave that part. Now to open and in immunity debugger, here in immunity debugger you can go to py command, download Mona and put Mona here. So we needed to get the SEH, and there are to find the POP POP return address. You can there are some other approaches if you are using other debuggers, but for immunity debugger you need to download Mono and copy it in py command. After doing all these ones, what you can do, let me file open. I'm gonna open this code B64 deck. The link to download it in the slate, you can have it. Open it. After opening, I want to run it. It's gonna stop where the input is getting input. I'm gonna download, run it. And here, instead of writing, it's for base64 decoder. You give a input, it's gonna decode it and save it in a file. There, I'm gonna input that 700 A's that I have and press decode. After pressing decode, this is the SEH chain. If you don't see that, you can go to view and SEH chain. After here, what you see that is 414141, which is corrupted and is the SEH handler replaced with 41, which is the ASCII for character A. Hex for character A. 414141. That's what happened. We know that we need to know that what's the exact location for this one. So we need to know how many characters we need to fill it with this one. If it's all A, we won't be able to do that. But I have it here in I use Metasploit. You can use Monad as well, but I'm using Metasploit MSF pattern create, and I'm saying that create a pattern of 700, and I'm gonna copy this pattern. After copying it, this time I need to open again, because when the exception happens, it won't do the we need to open the file again to be able to rerun our experiment. Okay, I'm gonna open it again and run it. It's gonna open the same menu. This time I'm gonna copy that pattern, and when I click decode, it's gonna show me this address 0236FFCC. What I can do, I can use again Metasploit MSF pattern to tell me that what's the offset for this one. let me write it. This time I'm gonna write 02 0 sorry 02 sorry, something wrong, because it doesn't say corrupted. It's supposed to get tell corrupted. There is it shouldn't be like this. If it's corrupted, then we can say that it's corrupted, then we can continue. Otherwise it's not correct. Let me pause it, find the issue. Let's see. Okay, I rerun it and this time it works. I didn't do any change, I just rerun it and it's working. So this time you see that it said cropped entry and it's showing 3775, and when I am using MSF again to say, tell me that what this address is, it's gonna show me the address is in 6200. This is the one, the numbers that we are looking for. So what we're gonna do, I'm gonna again open that file again, because it's already corrupted. And this time, before going ahead, I'm gonna go to show you how I write a code for what code I write it for doing a exploit, because we need to create a first we also need to create a shell code, a malicious payload. But for malicious payload, what I requested is this one. I want to create a code that running calculator and remove all the bad characters from that 000A and 0D, and it's gonna, I ask it to be in Python format. Let's see. After running it, give a sec to this. Okay, this is the code I have it. So we know that what the binary code, I can use it to put it in here in this part. Continuing to this one, what I can have it, let me jump to the code I have it. We are saying that we know that we need 628 character, but we're gonna after that we need to add it to the jump 6 character, which is EB80 and 9090 for no operation, and then this is the address we needed for pop pop return. Let me show you how to find the pop pop return from here. Here you see I can write it Mona SEH, and it's gonna open it. Let me see, it's gonna show it here soon. And in the meantime, I can show you here as well that I have it for pop pop return. There are some it's gonna show list of some places in the memory that the pop pop return are instruction one after each other, but among them we have, you see that it says feature ASLR false, rebase, safe SEH. The features we are looking for is that all of them to be false except SEH, and that's the address we're gonna use it. Let me see if it's brought me here in Windows. Here, that's what we can see it. Apart from that, here also SEH, you can see list of them there too, that is gonna after running it, it's gonna show you where they are. And what I'm gonna do, after doing this one, I took one of those addresses. You're gonna see it here in the log data. It's gonna show you where those pop are. These addresses, you can use those based on the features we were looking for it. After having this address as well, let's go to the exploit code that we're gonna write. The exploit code, we know that we need 620 characters, and after that we're gonna reach to the jump 6 character, and then the address for pop return. As I told you, the address over there. Remember, if the address is starting with 00, you need to remove it, and not remove it, you need to write it in a little Indian format, so it's gonna be at the end 861E40, because it's the machine I have is Little Indian. So the code I am gonna have it, we can put it there, and then write it in I can write a simple Python code to write these input into the, for example, crash 6.txt, but we haven't added the malicious code as yet. The code I created with the Metasploit, I can add it there, but since the code is big, we won't be able to add it directly in the buffer size, in the argument that they have. Maybe it's gonna cut up because it's bigger than the size. For that reason, we have a egg hunter approach. In egg hunter, it said that we're gonna put the shell code somewhere in the memory, and we're gonna tag it with something like, for example, ERCD, or repetition of this twice. And this way, we're gonna write a small piece of code to just checking the memory and find it when there is a ERCD repeated twice after each other, and then it's gonna jump the code to that place. ERCD can be anything else, but usually the security people use this one, or woot W00T. So we're gonna repeat their approach, but it can be anything. You can tag it anything. The code is very simple. You can also use Monad to create this egg for you. Otherwise, it's just a binary it's a simple code that you can have its binary, find it, and you can use whatever is in the slide as well. So we're gonna have our shell code added in the egg hunter. So what we can do, we can add it to say that have egg hunter ERCD, and for now we padded with no operation, but we're gonna add the shell code here. And then we have the address and then we added the egg hunter. We adding the job and return pop address here. The final version of the that we have it, after adding it, we're gonna have the payload, malicious payload that I get by using Metasploit. And then I'm adding egg hunter. I'm adding there is a point that whenever you are adding a egg hunt, this one, you have to calculate how many characters is, and this amount of characters supposed to be lengths of payload supposed to be decreased from that. And anytime that you are adding let's say no operations, padded with no operations, remember to decrease it from this number 620. This is the code. I have it, and in fact what I am doing, I am creating a buffer to fill up. Let me get back to the pictures that I have it here, to fill up these stuff here. So after what this code gonna, after running this code, I can simply use like let me bring it up. I can use I can write it in a Python code and put it compile it with Python. After compile, like this, Python this one, after compiling, it's gonna create me a crash code, and the crash, I have it here, I copied in Windows. Here I have the crash, this one, crash text. What we can do, we can copy this one. Let me Control C. I'm gonna copy this one, and then this time when I am running it, I'm gonna run with this input. So the expectation is that egg hunters search for finding the shellcode. When the shellcode happen, then it's gonna open the calculator. Let's try it. I'm gonna run it again. After running, I'm gonna have this screen. Sometimes this screen doesn't show, it's going down here, remember, like this. So click on it to be able to make it visible. I'm gonna copy paste the input that I have for crash and press decode. When I'm decoding, let's see the view SEH chain. You're gonna see that it's corrupted. To make that calculator happen, we're gonna continue it. What we can do, I'm gonna press Shift F9 to continue execution. I am pressing twice. Now the calculator open. That's how we can do SEH overflow.